Hello class, in this video I'll be showing you an application of the exponential growth and decay function. Let's begin. During an experiment, the number of bacteria in a culture was observed over time. At 8 a.m. there were 3,000 bacteria present. At noon, the number of bacteria in the culture had grown to 4,200. Assuming uninhibited exponential growth, how many bacteria will there be at midnight? Round to the nearest whole number. We will start by identifying some of the quantities in this problem. P of 0 is going to equal 3,000. And that's because the initial amount of bacteria in the culture was 3,000. And here we are assuming that 8 a.m. is T is equal to 0. P of 4 is going to equal 4,200. And that's because at noon, there were 4,200 bacteria in the culture. And here, again, we're assuming that 12 p.m. is T is equal to 4. We do not have a growth rate for this scenario, so I'm going to start by solving for K. So we have P of T is equal to 3,000 e to the KT. And we know that at P of 4, there were 4,200 bacteria present in the culture. So I'm going to clean this equation up a little bit. To solve for K, I'm going to start by dividing both sides by 3,000. Next, I'm going to apply the logarithmic property of equality. Next, applying the power rule, I'm going to convert the exponent to a factor. We know that the natural log of e is equal to 1, so we have k is equal to the natural log of 42 divided by 30, all divided by 4. We can get an approximate solution for k by using Decimus. So I've gone ahead and entered k into Decimus, and I let k equal this expression so that Decimus knows that k is approximately 0.0841180591553. And now that we have a value for k, we can go ahead and figure out how many bacteria there will be at midnight. So we have P of T is equal to 3,000 e to the KT. At midnight, T will equal 16. So we have P of 16 will equal 3,000 e to the 16 times k power. Now I'm going to evaluate this expression in Decimus. I've gone ahead and entered the function into Decimus. Notice that I replaced the t's with x's. I wrote k in the exponent because Decimus knows that k is equal to the natural log of 42 divided by 30, all divided by 4. And to show you that this equation is correct, I'm going to evaluate this function for when t is equal to 0. Notice you get 3,000. And when t is equal to 4. Notice you get 4,200. So now I will evaluate this function for when t is equal to 16. So when t is equal to 16, the function is equal to 11,524.8. Since the problem asks to round to the nearest whole number, that will be 11,525. So there are 11,525 bacteria in the culture at midnight. And we are done.